All right, good morning, everyone. Welcome to Ballroom BC. This next session is times and dates in Pandas. Make sure everyone's in the right location where you're intended to be. And please welcome Reuven Lerner.
All right, hello everyone. Welcome to this session, Dates and Times in Pandas. So first, a few words about myself. I teach Python and Pandas just about every day. I'm in a different city, country, either physically or virtually doing corporate training. I've taken my corporate trainings, I have recorded them. You can get them at lernerpython.com. I do a whole bunch of newsletters, including Bamboo Weekly, where every week I send out, I love the name. It was my father's idea. Puzzles about current events. Every Wednesday I send new questions, and every Thursday I send full answers, including Jupyter Notebooks. I'm on YouTube, and I have books, Python Workout, and as of 2 weeks ago, Pandas Workout, with more than 200 exercises to improve your Pandas and your Python fluency. But let's get philosophical for a moment. What is time? Well, actually, when we use the word time, we really mean two totally separate things. The first thing we mean is a particular moment in time. When was someone born? When a meeting starts? When a flight will arrive? When your book draft is due. Although if you ask my publisher, they think I believe that that is an imaginary number. And then we can also use time to describe a span of time, not one particular point, but a length. How long someone lived, how long a meeting lasted, how long a flight lasted, how long you were working with great love on your book. Now, Python and Pandas handle both of these, but because we have two different meanings for time, we need two different objects for them. So what do we use? Well, we actually can describe a moment in time as a date-time object. That is one specific moment in history or in the future. Sometimes in some systems we call these timestamps. But to describe a length of time, we use something known as a time delta. Sometimes people call these intervals. So let's do a little example here. So we had my schedule from yesterday, more or less. I taught a client in New York, then I went to the Education Summit, then I had lunch, then I did the decorator tutorial, and then I attended the opening session. So we can mark the start and end of each of these with date time objects. These are particular moments in time. But the length of each of these things we describe as a time delta. Again, we need two different objects because these are two different ideas, even though we think of them both as time. Well, we can do some math with these. We can say that a date time minus a date time is a time delta. So if the class I taught yesterday ended at 9 and started at 7, that's 2 hours. Or you can say the death date minus birth date is the lifespan. We can also do math as date time plus time delta is date time in the other direction. And we can also say date time minus time delta equals a date time, right? So if we have the ending time and we know the span and we subtract from that, then we get to the starting time. Now, why is this important? It's important because our world is full of this kind of information. When a temperature was taken from some sensor, when someone was born, when a politician started their term of office, when someone graduated from school, when someone got into a taxi, when someone started or ended their workday. This information is everywhere in our world, and so it's everywhere in our data sets. So let's say I have this data and I want to import it into Pandas. How am I going to do that? Well, if I'm really lucky, then I have my data in a binary format, like Excel. Okay, lucky is perhaps an exaggeration there. And I can import the datetime info just fine. But let's say that I'm a normal person. Let's exaggerate here, right? And CSV files are what I'm dealing with. And those are all textual. And the way that we then turn that into any sort of data is based on Pandas parsing it for us. Now, it's very good at dealing with integers. It's very good at dealing with floats. But dates and times, not so much, as we're going to see. So let's use one of my favorite data sets, New York City taxi data. This is data from January 2020. And I'm going to use read CSV to read in the CSV file. So here we go. I give the file name. I say pd.readcsv, give the file name. And then I say I only want a few columns from this file: the pickup date time, the drop-off date time, passenger count, trip distance, and total amount. So what did I get? Well, if I ask Pandas for the dtypes, it says pickup and drop-off date time our object. The rest are floats. So what's going on? Well, basically, as I said, Pandas does not recognize datetime columns automatically. We need to tell it, take these values and turn them into datetimes. By the way, if you use the PyArrow engine to import, it actually does recognize them most of the time automatically, which is kind of nice. So let's say I want to turn them into datetime objects. I can use the function in Pandas pd.toDatetime. And this function gets input as a series of strings, and it outputs a series of datetime values. And so if I want to convert a column from strings to datetimes, I run the function on the column, I get the datetime column back, and I assign it back to where it was. So here, for example, I can say pickup datetime equals pd2datetime of what it was before. And by assigning back to it, I change the type. And sure enough, it worked. If I say now df.dtypes, here we go. Pickup and drop off are all of type datetime 64 ns, meaning 64-bit, 8-byte value, down to the nanosecond. Here's another cool thing. It now uses 75% less memory than before because it is a 64-bit value as opposed to that huge string that we had before. So we save memory by using datetimes. Of course, we also get new functionality. Now, what happens, and I know this has never happened to any of you, what happens if some of the input values are invalid? What's going to happen then? Well, then you go back and complain to your users, right? They should not be doing such awful things. But basically, by default, we will get a value exception, stopping the entire import process because Pandas doesn't know what to do with it. So what we can do is we can set the errors keyword argument. We can say errors equals raise. Well, that's the default, so we don't have to say that, and that raises the exception. We can also say errors equals coerce, and then we will get a value for each input row, but it's going to be set to be NAT, not a time. This is very similar to not a number. It's sort of the equivalent. And so if I say here pd.toDatetime of dfdate, errors equals coerce, I will get datetime values in dfdate where the input string is a valid datetime value. But you know, it seems kind of annoying that I have to first read it as a string and then convert it into a datetime. Couldn't I do that all at once? And the answer is yes. If I use read CSV and I specify parse dates, I say these are the columns that contain date values, parse them as such, usually works great. And I pass a list of columns to treat as datetime, so it doesn't have to be one even. Now, this does not offer all the flexibility of toDatetime, but it offers an awful lot of it. For example, I cannot set the errors keyword argument, as I just mentioned before. But I can say, OK, let's do read CSV. Here's my file name. Here are the use calls, and parse dates. By the way, I can name the columns, but I can also use integers to indicate where they are in terms of the index. Well, what happens, though, right? How does Pandas know how to read it? How does Pandas know how to parse these into dates? And the answer is it actually works just fine with a whole bunch of date formats, especially the unambiguous common ones. But some of them are unambiguous. Right? Is 2/3/2024, is this March 2nd? Or is it February 3rd? So by default, Pandas assumes the month first format that's in the US. And might I add, only in the US. But by default, Pandas assumes that, but if we pass day first equals true, then it switches it around, right? That's not the default, but if we set it, then it's day, month, year. Well, what if I have a odd date format? Then I can give it a string. I say date format equals, and I give it a format string. And this works with both toDatetime and read CSV. Now, what does this string look like? Oh, it's the same as stir_p_time and stir_f_time, the formatting strings, where the string is taken literally, except for where you have percent followed by a time date marker. Wait, you don't remember all the codes for stir_f_time and stir_p_time? Here, I have news for you. No one does. No one does. Luckily, there's some great websites out there. stir_f_time.org lists all of them, and stir_f_time.me is an interactive thing that you can play with and see what it's going to parse. It's phenomenal. So how can I use this? Well, just recently I had an issue of Bamboo Weekly where I had time data that I wanted to import that was in a funny format. The funny format was month, day, year, hours, minutes, seconds, and then AM or PM. So I had to use that %p at the end, and I did read CSV. I said date format equals this. Boom. It was just read into Pandas, no problem at all. And then it is a fully fledged datetime object. Right? It's not a datetime object of a particular format. It's a datetime object. Okay. Hurrah! We now have date time columns in our data. Well, now what can we do? Actually, we can do an awful lot. We can use a lot of familiar methods. A lot of the aggregation methods, mean, min, max, they all work. Because at the end of the day, we're talking about numbers here. Right? We can even use the describe method to summarize our data. So if I do that here, and if I say df tpep pickup date time when the person was picked up in the taxi, dot describe, I get this whole series back. Count, mean, min, first quartile, 50%, third quartile, and max. I get all these values. By the way, this was taxi data for January 2020. The min is from 2003, and the max is from 2021. Yeah, data is not always so clean if you hadn't heard. So I can do more than that. I can do comparisons. We can compare date time values with strings. And if you just give the date, Pandas assumes the time is midnight. So if I say here, df pickup date time equals 2020-0101, so it's going to look for January 1st. It's going to find all the rows that are equal to that. And then I'm going to use df.lock to filter those rows. So now I find all those rows, only those, though, that started on January 1st at precisely midnight. What if I want to find things that are on New Year's Day anytime? Well, then I can be a little more sophisticated. I can say where it's greater than or equal to New Year's Day at midnight and less than January 2nd at midnight. Even better, if things are comparable in Python, right, if we have less than and equal on them, then we can sort them. And sure enough, I can say here, df.sort values based on the pickup date time. And this sorts the entire data frame, meaning it gives me back a new data frame based on the old one, based on df, in which the rows are sorted from earliest date to latest date. I can also say ascending equals false, and then it reverses it. So now we're getting it from the newest date, the latest date, to the earliest one. I can even use these amazing convenience methods, n largest and n smallest. I can say I want from my data frame the 3 earliest or the 3 latest times and dates, and it will give them to me. I can ask all sorts of interesting questions, like what was the mean trip distance on New Year's Day? How far did people go? So I can say here, give me all of the rows on New Year's Day from midnight until midnight of the next day, then pull out just the trip distance column and calculate the mean. And we find out it was 3.49 miles. Okay, well, what if I want part of the date time? What if I want to grab something from there? Well, I can do that. There's the dt accessor, and that is our gateway to elements of a date time. I can say pickup datetime .dt.hour, and then I get back a series of integers, the hour value from each and every one of those rows. Well, what else can I get in addition to the year? Well, in addition to the hour. Well, I can get the year, month, day, hour, minute, second. I get the quarter. I get the date, that is just the date part. I can get the time, just the time. And I can even get the day of the week. I can get some Booleans back. Is it the year start? Is it the year end? Is it the quarter start? Is it the quarter end? Is it the month start? Is it the month end? Is it a leap year? How many days are in the month? And we even have methods, not just data, but methods, month name and day name. With this in place, we can ask and answer lots and lots of questions. For example, I could say, tell me what percentage of taxi rides took place on each day of the week. So I go to my data and I say, give me tpep pickup date time, dt.dayname. Okay, so that's going to give me back the day name. And then I'm going to ask for value counts on that. Value counts takes a series, and it counts how many times each value appears there. Each independent value becomes the index in the series we get back, and then the values of this new series are the counts, value counts. And if I say normalize equals true, it doesn't give me the raw numbers, it gives me the percentage. So sure enough, I run this, and I get back here, and I see, and by the way, value counts sorts from most common to least common. So in January 2020, most of, or the greatest percentage of rides were on Friday by a hair. And the smallest percentage was on a Sunday. Well, I can go even further than this. I can say, you know what? Give me pickup date time dt hour, each hour of the day. And then, now that I've found out the hours of the day, let's do a histogram. Now, normally a histogram gives me, by default, 10 bins. But I can say, give me 24 bins, because, as you might have heard, there are 24 hours in a day. And here we go. Now I know, in general, how many rides, I know for that month, how many rides took place at each hour of the day. And we can see, shockingly, that 4 a.m., not so popular. About 6 p.m., I'd say, very popular. How long were these rides, though? How long did they take? Well, to answer this, we're going to need to use our other date time or date and time related data structure. We're going to need a time delta. So how am I going to do that? Well, we saw before with our date math. I can subtract the start time from the end time, and then I assign that to a new column, and that's just what I'm going to do. df of trip time equals df of the drop-off date time minus the pickup date time. And now I can ask, how long were the rides? Well, I just go to df trip time, and we get these values. And the way they're displayed, by the way, is a little weird, but this is standard in the time delta world, right? It's how many days, and then hours, minutes, and seconds. So, okay, that makes sense. That looks pretty good. And you can see that the d type of this column is indeed now time delta 64. It is not a date time, it is a time delta. Well, what can I do with a time delta? It turns out that it has only 3 parts to it: days, seconds, and microseconds. So you can pull each of those out. And how do you do that? Use the dt accessor, just the same as a date time, even though it's a different data structure. But we also have one more thing we can do. We can invoke the total seconds method, which gives us back an integer. How many seconds total was that? Well, are there methods that I can run on them? Yeah. I can run all the methods that we talked about before, all these aggregation methods. I can say, describe, and it tells me the mean, the standard deviation, the minimum, the wait. Minus 2 days. 5 days. Is there negative time? It turns out that yes, actually, in this data set, we had a whole bunch of taxi rides that were negative. And I don't just mean a negative experience. What the heck is going on? Well, as someone wise said to me many, many years ago, computers don't do what you want them to do. They do what you tell them to do. And here we said, subtract one time from another time. And the computer said, okay, boss. And this is what we got. So we can do comparisons also. I can compare a time delta column with a string, right? The same sort of string we saw before. How many trips were greater than 0 days, 1 hour in length? I can also say, based on that, find all the trips that were greater than 0 days, 1 hour in length, and then use that inside of df.lock to find all of those rows, then get me the trip distance and find the mean. This means, in other words, what is the average trip distance for trips that took longer than 1 hour? But you know what? I can express that in a totally different way. I can say trip time is greater than 1 hour. Pandas is smart enough to take those sorts of strings and compare them. It knows what to turn them into. And so if I can even do something else. I can say, tell me, how many trips took longer than 3 days? And the answer is 4. Wait, what? We're going to get back to that. I can retrieve multiple columns via df.lock. So I can say, find me all the rows in which the trip time took greater than 3 days, and for all of those miserable people sitting in a taxi for 3 days, how far did they go? And how much did they pay for the privilege? This is why data science is so fascinating, folks. We learn about humanity. And basically it says that here we had 4 different trips. They did not actually go very far in those 3 days, but look, one of them spent $4,268 to go 1.5 miles over 3 days. Friends, I have found the taxi they were in. All right, here's another fun thing to deal with time. And by fun, I mean, oh my God, it's so awful, time zones. So datetime values can optionally include a time zone. And so there are a whole bunch of scenarios because we have our data that we're reading in, and then we have the values that we actually want. So what can come up? Well, we can have naive time, meaning no time zones. We can have the data specifies the time zone, and then we want to have that time zone in our values. The data does not have time zones, but we want to give it a time zone. The data lacks time zones, but we want to give it a time zone, specifically UTC. And then, what if every single record has a time zone, a different one? So let's go through a few of these scenarios. So if it includes the time zone, actually, it's not so bad. Here is an example of some entries from an old server I used to run. You can see that each of the date time entries includes the time zone. So if I include %z in the date format, right, like I did at the bottom there, it comes in with a time zone. And the result of doing this, here we go. We can see now that I brought in these times, and the D type includes the time zone, UTC plus 2. Well, what if I've read in naive values without a time zone, and I want to give them a time zone? I can use TZ localize. And so what I do is here I'm going to have my pickup date time. I'm going to run .dt.tz localize on it. I'm going to say I want to make it Chicago. And then I bring it back. And what do I get? Look at this. Now the D type is datetime 64 set to Chicago. I can do basically the same thing with UTC, but I don't need to use any sort of translation. I can just say UTC equals true. And then Pandas is fine with that and does that. And sure enough then, the D type is going to be datetime 64 with UTC. What if every record has a different time zone? First of all, then I feel for you. But Pandas will then store each value as a separate timestamp object, keeping the time zone, and then the D type is object, because it's referring to Python objects, not keeping it within NumPy and Pandas. But once we've done that, if we have that, we can run toDatetime on that series, force it to use UTC, we get it back, and now we're okay. And it'll do the translation there. What if I've got it in one time zone and I want to convert it? I've got convert, TZ convert, I should say. So I run TZ convert and I say what time zone I want to get back, and then sure enough, I get that. And this is exactly the same time, it's just being displayed differently because it's in a different time zone. Okay, so we've got our data read in. We've got it in the right time zone. What can we do with it? Well, one of the most common things we're going to want to do is grouping. So for example, I can ask, what is the mean cost of a taxi ride? Well, I can just say df of total amount dot mean. And I get back the mean amount of the taxi ride. But now I want to ask, what is the mean cost of a taxi ride for each hour of the day? And this is a classic example of what we use group by for. What do we do with group by? We need a categorical column, we need a numeric column, and we need an aggregation method. And then we say, general sense, group by, what is the categorical column? Meaning we want to run our method here, the method at the end, on all the numbers where the category matches, right? Or said a different way, for each unique value in categorical, run method on the numeric column. The thing is that the categorical column here should be each hour of the day. How do we get that? And the answer is actually surprisingly straightforward. Normally in group by, we give strings to name the columns we want to use, but we can actually use dt.hour instead. I just say group by, df pickup datetime on .dt.hour, and it works. Here we go. Now I have the mean cost of a taxi ride for each hour of the day. And because group by automatically sorts the index of its results, we get it from midnight until 11 p.m. Works pretty great. Well, wait a second. I can plot this. I can do the group by, and then I can say .plot.line, and I get this. We can see now how much did people pay for taxis at various hours of the day. And remember we saw that there were very few taxis, right, at 4 or 5 a.m.? It turns out, maybe not a lot of taxis, but they are raking it in compared to other times of day. Well, how about we get a little more sophisticated? What is the mean cost of a 0-passenger taxi ride for each hour of the day? So what I'm going to do here is I'm going to use .lock and lambda. I'm basically going to say, show me all of the rows where the passenger count is 0. And then what we get back, right, so we're not working on the original df anymore. Now I'm going to say group by df pickup datetime. And then we can plot that thing, and we see this, which is roughly similar. Not exactly the same, but roughly similar. But do you see the problem here? Do you see the weirdness here? How can this work? Using lock in that first line, I filtered out all the rows, or any of the rows that were not 0 passengers. But then I did the grouping on something based on df. But we're not working on df anymore. We're working on something on a subset of df. That's okay. Pandas actually is willing to ignore the indexes that are not in the data frame on which we're running the group by, which makes it really convenient to use method chaining in this sort of way. Well, if you like grouping, you're going to love pivot tables, because a pivot table is basically a 2D group by operation. So you're going to need 2 categorical columns rather than just 1. One is the index, that is the rows, and the other is going to be the columns. So can we use part of a datetime column to create a pivot table? So for example, let's say I want to do categorical day of week, that's one categorical, and another categorical is going to be number of passengers. So basically I want to find for each day of the week and each number of passengers, what is the mean total amount, the average amount that they spent. And I can do this here this way. I do df.pivottable. I run the pivot table method, and I say what is the column on which I want to do the rows, index equals, and here I can do the same trick as before. I can say df tpap pickup datetime dot dt dot day of week. So those will be my rows, and indeed, when I do the pivot table, I get this. Along the rows, I get the days of the week. Along the columns, I get the passenger count, and I have here for every combination of day of week and passenger count, how much did they spend on average? Well, what if I want to do chronological grouping? That's a grouping usually looks at every unique value in a categorical column. But what if we did it chronologically? What do I mean by that? I mean, we take the earliest time, the minimum time, and we take the latest time, and we chop it up into pieces in some sort of frequency, in some sort of even pieces, and we say for each of these pieces, what is the value? Right, so I'm really saying I want to give results for the first 24 hours, then for the second 24 hours, then the third 24 hours, and so on and so forth, until we get to the final 24 hours of our data. So how can I do that? And just to emphasize this is very different than what we did before with the group by, because the group by said, I want to take all the unique values for day. Here I'm not saying unique values, I'm saying from the earliest to the latest, even if we don't have data in the middle. Well, it turns out that there's a great way to do that in Pandas, and that is grouper. And basically, what does grouper do? With grouper, we tell Pandas which column do we want to use, and what granularity do we want to use in that analysis. And the returned object, what we get back from grouper, is designed to be used in a group by or in pivot table. Now, the granularity is yet another thing. It's sort of like stir f time, stir p time. It's a bunch of characters that are kind of hard to remember. And by the way, the latest versions of Pandas, they've been changing it around a little to make it more consistent, but sort of annoys people who have been doing it for a while. You can always go to, and I don't expect you to remember this, right? But you can always go, if you can, bully for you, right? So you can go to the Pandas documentation and get a whole list of what are the offset aliases, as they call it, and it's all sorts of things, right? It's like day, month, year, and you can put numbers in front of it to say 1 day, 2 days, 3 days, and so on and so forth. So what are we going to do with grouper? Oh, by the way, grouper is not only for datetime values, but that's a very, very common use for it because it works so well with them. So let's go back now, and let's say I want to find the mean taxi fare for each week. For each week, so meaning the first week, the second week, the third week, the fourth week, how much did people spend on average? So I can do this. I can say df.groupby, so I'm going to do a group by, but the argument to the group by is not a column. The argument to the group by is this grouper object, where I say the key is tpap pickup datetime, that's the column, and the frequency is 1w, 1 week. So I want to get this. Well, let's think about it for a moment. I want to know the mean taxi fare for each week in the data from January 2020. Luckily, we know that 1 month contains 4 weeks, so we will get 940 results. That's a little more than 4 for those of you who are weak on math. What the heck happened? Actually, it's pretty straightforward. Remember that it takes the earliest time and the latest time, and it chops it up, and it gives us a result for each of those, even if there is no value there. And indeed, we see here, we have nan. So it's going from the start to the finish, the earliest to the latest, divides it up, and we get nan somewhere. This means that if you have any outlier datetime values, that's going to have a pretty dramatic effect on your results. And you will probably, not definitely, depends on what you're doing, but you'll probably want to use drop NA to remove those. And if I do that, I suddenly discover that the group by result has 20 rows, not 940. Now, 20 is still greater than 4, but that at least reflects the weeks in which I have actual data as opposed to the spaces between those weeks. Right? You can imagine if this data included one date that was accidentally from 100 years ago, grouper and group by would give me all of the weeks from 100 years ago until now with a lot of nans. So can I do a pivot table with grouper? Yeah, absolutely, I can do that. And we won't have any nan problems here. So what is that going to look like? Well, I'm going to say df of pivot table as before. And remember, pivot table requires two categorical columns. One categorical whose unique values will be along the index, and the other categorical whose values will be along the columns. So here I say index equals PD grouper. The key is pick up datetime. And I say frequency equals 1 ME. 1 ME means 1 month end. Okay? Now, why would I say month end? Because you can also say month start, and then you'll get different values displayed, as you'll see in just a moment. So the index here is going to be this. The columns will be the passenger count. Values will be total amount. The ag func will be mean. And I get this pivot table showing me for every week, for every month, what did I say here? 1 ME. So it's every month. Good thing I'm in charge here, right? Oh, great. No, Keynote is in charge. There we go. For every month. And notice what we get here in the index. It is always going to show us the final day of each month because I said 1 ME. So the end of January 2003. Then we skip to the end of December 2008. Then the end of January 2009. How these data points got in there, I'm not sure, but they did. Well, what if I want to index with a datetime? Remember that in Pandas, the index for a data frame can actually be any column at all, any values at all. And that includes datetime columns. So if I do this, if I turn a datetime column into my index, that turns our data frame into what's known as a time series. And this turns out to be very common and very useful. So I can just say df equals df.setIndex of tpep pickup datetime. By the way, setIndex, like many other methods in Pandas, you can set in place equals true, and then you don't get the result back, but you change it. Don't do it. Stop using in place equals true on all of your methods, including this one. Okay, now that I've done this, let's look at the index. What is the index now on df? And the answer is, it's a date time index. It's a special kind of index containing dates and times, like hence the name. And we can see then, that's what we got. And the D type is even going to be datetime 64. Okay, now what? What have I done? How does it really help? Well, it turns out that if I want to retrieve rows from a time series like this, well, I can retrieve with .lock and a full date time. So I can say df.lock of 2020-0101, 002815. Show me all of the rows where the person was picked up, because that's the index, at, on January 1st at 28 minutes and 15 seconds after midnight. And that will work just fine. But if you leave off the fine grained measurements, they become wildcards. For example, if you leave off seconds, it matches any number of seconds at 28 minutes past midnight. If you leave off the minutes, it matches any minutes and seconds so long as the hour is midnight. And if you leave off the time, it matches anything on that date. And so I've found it might not be faster, it might not be more efficient, but boy, oh boy, is it easier to sort of keep track of if I sometimes set a column to be the index with set index. I use .lock in this way, and then I reset the index. Well, resampling is another thing we can do only if we have date times as the index. And it's similar to grouper's effect, but we don't need to use group by. Now, you can only resample, as I said, if the index contains datetime values. What you do is you specify the frequency. Yes, the same types of frequencies we saw earlier with grouper. You say the column or columns on which you want to calculate and what aggregation method you want to use. And once again, as we saw before with grouper, you will get nan values whenever there are periods without input data. So let's see how this looks. So I can now say df dot resample on 1 ME, that means 1 month end, on total amount for mean. What am I trying to do here? I'm trying to find out for each month for which I have data, from the earliest to the latest, I want to find out the mean total amount. And what do I get? Look at this. I get a series back. All right, and it says here, right? 2003, and so on and so forth. Did I do a drop NA? Yes, I did drop NA. I was like, wait a second, where's the NAs? There we go. I followed my own advice. Who knew? So here we have the series in which we have all of the months in which we have at least one data point. We calculated the mean, and we can look at that. All right, to summarize, Pandas offers a lot of rich date time functionality, and I want to stress, I've worked with a lot of people over the years. Even many people who have worked with Pandas for many years aren't really familiar with all the stuff that it does with dates and times. And so I hope this opened your eyes to a bunch of it. How we can turn textual data into datetime values, how we can extract elements with DT, how we can create time delta objects with datetime math, how we can compare and sort datetime values, how we can work with time zones, naive datetimes, UTC, and converting them, how we can use it for grouping and pivot tables, and how we can create a time series and then retrieve from it as well, and then, of course, resampling for chronological grouping. All right. I think we have time for some Q&A. I'd be happy to hear from you. Thanks very much.
Any questions?
Hey, so we have an Oracle database that has a lot of mixed date times inside of it. It's very fun. And I'm just wondering, what is some best practices for when I extract those rows? Should I be converting these dates sort of on the Pandas side? I could be doing them on extraction. I know the best practice is really I should go in the database and fix it all. That's not happening. It's not mine. So I'm sorry. So if you could provide any tips, thank you.
I don't have a great answer for you. I mean, you answered it yourself, which is the ideal is to do in the database. Okay, but we don't exactly live in an ideal world. I'm guessing that doing it in Pandas will take longer or use more memory just because you're creating all these timestamp objects and then doing the conversion. And if you have a lot of data there, that's just a lot of stuff that's going to be having to deal with. And so whatever you're using to extract the data, that might be a better place to do it before it even gets to Pandas. I would suggest trying that, but it might be worth doing some little experiments just to see sort of what is faster. And you also know your data, you know how much you have. If it's not that big, then it doesn't matter that much. Oh, yeah, well, then it might matter. Or if they pay you by the hour, do it in Pandas.
All right, next question over here.
Hey, thanks for the talk. As you said, even with years of practice, you may not ever really master dates and times. So I was wondering, have you found that LLMs and ChatGPT or similar technologies help with this?
Yes. Okay. So look, I would say ChatGPT is like the best $20 I spend each month. Now, granted, I'm a freelancer. I work by myself. So I'm constantly using it for like doing copy editing, and I ask it to do all sorts of like going over my technical stuff. That said, 90% of what it says, I know, like I already knew, I don't need its advice. A bunch of what it says is just plain old wrong. So to accept it blindly is foolish. But there have definitely been times when I say, you know what? I am not interested in looking up this stirf time string. ChatGPT, do it for me. But then I don't trust it. Then I check it, right? Like I use it as sort of doing a first draft for me rather than writing my code for me. And I think there's an important difference between the two. All right, and definitely I've been in many situations where I ask ChatGPT to write Pandas code for me, and I'm like, you've got to be kidding me. And I'll say to it, are you sure that's really a good way to do it? And it is such a suck-up. It's like, oh, you are right. Thank you for pointing that out. That was a terrible way to do it. Let me try again.
All right, next question.
So I saw when you were working with resampling that by and large you're working with datetime index. I know there's an alternative period index, but is usage of that an ANSI pattern? Is there any performance benefits from using that versus datetime index? It's just sort of like what are the best practices on which kind of date index to use?
Quite frankly, I don't know. I don't know. I've rarely used period index, so that's a great question, though.
Hey, thank you for the talk. So you mentioned that using in place equals true is bad. Could you elaborate why?
Yes, it's very bad. No. So here's the thing. The assumption in the Pandas world among many people is that if I invoke a method and I get back a new data frame, well, that's like doubling my memory use. So I'm going to do it in place, and then it'll just change things there, and it won't use that much memory. And the Pandas core developers have tried desperately to make it clear for the last few years, this is a false assumption. You will not be using more memory. You can't sort of predict with that sort of accuracy what's going to happen. Please stop using in place equals true. And they've been saying it's deprecated or will be deprecated at some point in the near future. Like, please wean yourself off of it. Part of the reason is this memory stuff. And part of the reason is they're also trying to encourage us to use more method chaining. And when you use in place equals true, you get back none. And then it's a full stop. You can't do method chaining. Whereas if you get back a data frame, then you can do the sort of stuff I was showing here, at least in miniature, where you can just chain and chain and chain and keep going there. You should expect at some point in the future in place equals true to just go away, though. And so anywhere that you can extract it, remove it from your code is good.
All right, next question here in the back.
Yeah.
Hi, follow-up question to that. I was watching that as well, and it seems like you got a new data frame back, but you reused the variable name. It's still df, so you're getting a new one back with the same old name. So it's the same logical result, right? And I was just wondering, like, that I assume that's on purpose, and I don't personally do that because I like to be able to trace my steps. And did you have a comment about that? Maybe like renaming each new data frame based on what you're trying to do with it.
So first of all, I'm not. Let me start back for a moment. First of all, there is a difference. There is a difference between modifying in place and assigning the result back to a variable, because modifying in place means it's the same object. And if someone else is referring to that object, they will get that mutation, and it'll be visible to them. Whereas if you get a result back and you assign it back to the variable, if someone else is referring to that old data frame, they will continue to refer to it. You can't refer to it because you don't have a name to go to, but they will, and they won't see the changes that you've made. It won't be reflected in that. But logically speaking, it should be the same unless you have that sort of situation. Now, in terms of like giving new names to data frames, I don't think that's a bad idea. I tend, again, increasingly to use method chaining, and so I'm rarely like assigning to. I'm rarely like assigning that way. In fact, often I'll do within a method chain a set index, and then I'll get back a new data frame and I'll mess with it. But the data frame itself, the original DF, will not be modified at all. It's still going to be referring to that same old object, both before and even during and after my method chain.
Sorry, should have taken this off. So I work with a lot of dates that don't have time, dates of birth, other things along that line, and I'm used to languages that have a date-only format. There seems to be one in Pandas, but it seems to not work very well. Do you have any thoughts on that?
I believe you're right that it does have one, but I don't know much more than that. I want to say that it might be part of like the new-ish sort of Pandas native dates as opposed to like using the NumPy dates. I also want to I think this is true, that if you use pi arrow in the back end, that it has date as opposed to date time. But again, I'm not 100% sure that's true.
Thanks for the talk. I think the Pandas datetime is very powerful, but I think there is also a limitation that it has a relatively small limit. Like you cannot get a date over year 2262. So do you have any recommendations if my data contains a lot of out-of-range datetime?
No, that's a really good point. But well, I'll tell you, actually, I might. So I know that if you use the Pandas standard datetime object, it is, as we saw before, 64 bits and has nanosecond sort of granularity. If you read it in with pi arrow, you get datetime 64 with second granularity. And it might, again, I'm guessing here, that might then shift it to allow it to be further on in time. I'm not sure.
Great talk. Thanks for covering this. Do you have any comments on, we talked a lot about input from CSV. Do you have comments on what data scientists should do to preserve granularity, precision, time zones in terms of I/O formats when they're outputting data and then perhaps reconsuming it later?
Look, I think it's good to keep a time zone on there. Like, even if it's UTC, you could even argue, ideally it's UTC, because then it's standard across all these different systems. You don't have to mess with all sorts of stuff. I mean, if you can output in a standard ISO format with UTC, everyone wins. And that should be, I would think, like my gut instinct is, that should be the easiest thing to do. And yet it seems to be like rare or far too rare.
All right, any other questions? All right, let's give them a round of applause.
Thank you so much.